for joining me for this presentation today. I appreciate there are a lot of great talks on today, so I appreciate you spending the time to come to my session. My name is Grace Jansen. I am not from Germany, although my surname is Dutch. I speak no Dutch. Please don't test me. I'm actually from the UK, and I work at IBM. Before I kind of got into technology and software development, I did a biology degree specializing in fish, which you can imagine has come in really helpful in software development. But yeah, I've kind of had a weird and wonderful route into technology, so if you want to chat about that with me after, I'm here for the rest of the day. But now I work mostly in cloud-native Java, so around technologies like on my shirt, microprofile, TKTE, and OpenTelemetry, hence the t-shirt, making it nice and easy for you. So yeah, and today I'm going to be focusing mostly on one of the microprofile specifications and another open source project that's sort of based on called OpenTelemetry. We'll be looking at sort of how we can enable effective observability specifically for cloud native applications. Now, my title is deliberate. Does anyone know where the phrase "through the looking glass" comes from or originates? Oh, we got a hand at the back. If you can shout, I'm up for it. Yes, you've seen the movie, or you were just here for my second slides preview a minute ago. So yeah, Alice in Wonderland is where this phrase comes from. So if you've ever seen the movie, you'll probably be familiar with it. There was a recent movie released, but of course this dates way back to the sequel of the original book that was produced way back. So yeah, this is kind of, if you've seen the film or read the book, this phrase is all about Alice stepping through this mirror, which is obviously what they called a looking glass, to be able to enter into this magical, mystical world of Wonderland that she couldn't see before. And actually, this sort of metaphor of being able to step through this portal into another world is one that's repeated in other media and films. So if you've not seen Alice in Wonderland or this particular Through the Looking Glass film, you may be more familiar with this film instead. Anyone before I start playing? No? You'll know it as soon as you see it. It is, of course, The Matrix. So actually, in The Matrix, if you think back to this film, they actually refer back to Alice in Wonderland time and time again. In fact, so if we look right back to the beginning, when Neo is woken up by his computer, it actually sends him a message saying, "Follow the white rabbit," just like in Alice in Wonderland. And then when he's offered the red pill or the blue pill, they say, if you take the blue pill, the story ends, you wake up in your bed and believe whatever you want to believe. If you take the red pill, you stay in Wonderland, and I show you how deep the rabbit hole goes. So this kind of analogy is used time and time again to explore this potential of being able to step into this other world. And this is kind of what I wanted to portray with the title of this presentation today, in terms of this is all about us being able to step into this cloud-native world that we haven't necessarily been able to do effectively before now. So being able to create this effective portal so we can see into our cloud-native applications and understand how they're behaving in real time. So hopefully I've now explained the title and it's a bit clearer. So for the agenda today, what I want to go through is essentially why we need observability, what I mean by this term observability, how we can do this in our applications, and specifically, as I mentioned, looking at OpenTelemetry and microprofile telemetry to do that. And of course, we are developers. I have a live demo because we love to see code. So I promise there will be code. Just bear with me for a few slides beforehand. And then at the end, just in case I don't put enough links on the slides and you really want some homework, there's a whole resources page, so stay tuned for that. So the first question is, why do we need observability? And really this stems from the fact that both our infrastructure and the architecture of our applications has evolved sort of in tandem together to the point where we now have cloud native infrastructure and cloud native applications. So, you know, what we used to use was maybe a single core, but now we can take advantage of multi-threading, multiple cores, we've got virtualization, containerization, and what this brings is also added complexity as well as innovation and advantages like flexibility, portability, speed, resiliency, and the same can be said for the evolution of our applications. We've gone from more monolithic applications to something similar to either macroservices, microservices, or even serverless, depending on your application architecture. And again, this adds additional complexity. So why do we do this? Why do we want to move to the cloud if all of this is making our lives harder? And I think the main reason, bear with me if you've seen this slide before, I can't stop putting it in my presentations because I love it, is this. This is the reason. This is the feeling we get when we think about cloud native. This, ooh, the cloud. We get excited as developers because it offers us these advantages and this innovation that we didn't get previously. And so we want to be able to take advantage of this and use this and move our applications into this sort of space. However, we don't always feel like this when it comes to actually implementing our applications and making them cloud native. What it can often feel like is a little bit more like this. This is probably more realistic in terms of the frustration and sort of the angst of trying to pick the right framework, use the right tool when you've got a plethora out there, and architect and modernize your application in the right way to effectively make use of the cloud. And this isn't sort of a new paradigm. This is something that we experience time and time again as infrastructure changes, as our applications change. However, sort of the reason that it's so hard when it comes to cloud native is really the fact that we're now moving to distributed sort of infrastructure, and the fact that it can be hard to be able to understand how our applications are behaving in real time, whether they're healthy, what the root cause is of a potential problem, and how we can fix that. And so this is where telemetry comes in to sort of help us with those core questions. And actually, this topic of telemetry is becoming more and more prevalent when it comes to sort of guidance and methodologies that you can use and are advised to use to make cloud-native applications that are effective. So, for example, what came from the original 12 factors has been expanded and modernized to be the 15-factor app methodology. If you want to find out more about this, I did write a blog at the bottom here. Basically, what they did was they kind of expanded some of the original 12 factors, and they added in 3 additional factors. Can anyone see the 3 additional factors? Yeah, I made it easy because it's already the end of the day. I highlighted the additional 3 factors. So we've got API first, telemetry, and weirdly, which I thought was odd, there was no mention of security in the original 12 factors. So a very important 15th factor here of authentication and authorization. But really the one that I'm focusing on today is this addition of telemetry. Being able to have those real-time metrics to understand how our applications are behaving, to be able to improve performance, ensure reliability, and to be able to, as I said, make our applications effective in the cloud. So this is my kind of why we should be caring about observability and why I'm giving this session today. Hopefully, the passion in my voice has convinced you that you need to be concerned about observability. So now that we moved on from the why, we can look at the what. So what do I mean by observability? Because often when it comes to terms like this that can be quite broad, it can be a little bit confusing as to what we exactly mean, because it can mean a plethora of different things. So I've tried to provide sort of a very succinct definition here of what I mean by this term. When it comes to observability in general, this tends to be how people sort of describe it and define it. So really this is about understanding the internal state of a complex system based only on its knowledge of external outputs. This all comes from control theory. So this is an area of engineering that's concerned with sort of automating a dynamic system. So if you think of water through a pipe, for example, or the speed of a vehicle over inclines and declines, this is kind of where this term originates from. But what we really want to know is, okay, I don't want to know in general, I want to know how this applies to me. So what about in IT and cloud computing, which is what we're sort of focusing on here? And I've highlighted the key points in this to try and make this a bit more succinct. Really, what this is all about, what observability is about aggregating, correlating, and analyzing a steady stream of data, normally performance related, and being able to use that to monitor and importantly, troubleshoot and debug our applications as and when they happen. So that's kind of what we're talking about here and what we're trying to achieve when it comes to creating observability in our applications. Okay, so now that we're all on the same page with what, how about the how, which is kind of why we all came here today, hopefully. If you didn't, I will forgive you for leaving the room. No problem at all, no hard feelings. But essentially, this is what we're focusing on. How can we enable effective observability in our cloud-native applications? And really, I think that, conceptually, this is fairly simplistic. There are 3 key steps. It's just actually how we practically implement it where it can get a little bit more complex. So to enable observability in our applications, step 1 is instrumentation. So we need to actually enable our app to be able to collect that relevant data, whether that's metrics, traces, logs, or anything else that we want to collect. Step 2 is about sending the data somewhere. It's all well and good if you enable your application to send out data, but if we're not actually doing anything with it, we can't gain key insights and information about how to deal with it or what to do. So sending this data to something that can store and analyze it. And then the third step is providing visualizations and insights into that data. So being able to do things like query capabilities, being able to visually see this data so we can understand key trends and changes in that data to identify potential problem areas, bottlenecks, or failures. So as you can see, conceptually fairly straightforward. For step 2, we're kind of looking at things like, for example, Jaeger, Zipkin, Hotel Collector. There's a bunch of different tools out there that you can make use of that you can export your telemetry data into. And step 3, again, there's a lot of different open source tools you can make use of, like, for example, Prometheus, Grafana, Kibana, depending on your tool of choice and what you already utilize. There's lots of different ways in which we can graphically and visually represent and understand the data. So we're not going to be focusing on those 2 steps today. In this presentation, we're going to be focusing on, okay, how do I effectively instrument my system to be able to produce data that's going to enable me to understand it in these later steps. And so in order to do that, I'm going to refer to these pillars of instrumentation. Generally, there are 3 pillars that we referred to, and this is logs, metrics, and distributed traces. Now, that's not to say that these 3 are the be-all and end-all. We're always learning, we're always improving, and there are additional pillars that we can add to this, and the hope is that these will be added in later years into projects like OpenTelemetry. And they include things like end-user monitoring and profiling as examples, so being able to, for example, like gain real-time visibility into how users are experiencing and tracking through our applications, and profiling to be able to understand sort of how much time our code spends with particular hardware resources, for example, like how much time do we spend with, or how much memory and CPU do we spend for a particular, even line of code, if we can get to that level of detail. So these are kind of, the aim is that these will be added in later years, or hopefully sooner than that. But at the moment, we're just focusing on these core 3 pillars: logs, metrics, and distributed traces. And you're probably familiar with a lot of them already. It's about how we can utilize open source standards to be able to enable them. Now, is anyone unfamiliar with logs in the room? Because I know that sometimes we get students and stuff and they're not necessarily familiar. No. Perfect. Oh, yeah, that's fine. You got a hand, no problem. I have a slide for this. So hopefully this gives you a brief intro as to logs. Most systems, most applications, you'll already be using logs, and that's a great first step to being able to enable you to understand what's happening within your application, understand issues or errors that might occur, and why. Now, a log is essentially just a time-stamped message. It's pretty simple, fairly straightforward. Normally, it's all about sort of just emitting this log and being able to understand system behavior in quite a simplistic manner. You can use sort of logging systems that are inbuilt into your runtime. That's often what people use. So, for example, OpenLiberty, which is the runtime that I work with, we have a logging component that you can make use of that sort of handles all the messages that are written by applications in the runtime, and it can provide you with like data capture systems, etc., to be able to understand and collect those logs. But the issue with logs is that, as I said, they're fairly simplistic. They are not necessarily associated with a particular user request, for example, or a particular transaction. Because as we've gone to cloud native, we've now often got multiple microservices, and your request often has to go through multiple microservices to be able to actually complete a particular request or a particular thing that it's trying to achieve within your application. And so being able to track where in that process the error occurs and why can be very important, and that's not something that is enabled by logs. So great place to start, but not necessarily giving us the context that we need. So metrics kind of go one step beyond logs in terms of metrics are all about sort of more numerical data that we can use to be able to have like mathematical or probabilistic or statistical transformations on to be able to understand how our application behaves over time. So for example, number of system error rates, how our CPU utilization is occurring over time, request rates for a given service, for example. So this allows us to be able to sort of better trigger alerts because we can run queries against them. It allows us to understand not just our application at a snapshot like a log would, but it allows us to understand that over a period of time and how that behavior is changing. So metrics can be extremely useful in terms of understanding that system behavior. In order to implement metrics, like I said, with logs, normally it's just inbuilt into your runtime. You can just use the features that are provided there. With metrics, there are additional sort of capabilities and features that you can utilize on top of your runtimes to be able to enable more effective metrics. So one example is microprofile metrics. Has anyone come across microprofile? Yeah, great, a few hands. Okay, I see some hands not raised. So I'll quickly recap it. It is a community-driven specification that was really introduced to be able to offer innovations and APIs and features that weren't necessarily being offered at the time in sort of the core Java or by API or by sort of runtimes. And essentially it's built and developed by a huge community of different people, individuals and vendors alike. And it offers the following APIs. The latest version is version 6. And there are some new APIs that have come out in that. And as I said, the great thing about this is because it's an open source specification, an open source standard, you don't have that vendor lock-in that you might have with alternatives. So you can actually switch between different runtimes without having to change too much within your code, as long as they're a compatible implementation. So in terms of compatible runtimes, there are lots that you can choose from loads of different vendors and companies. So you might have heard some talks already around Quarkus or Wildfly or Pyara. We've got OpenLiberty there, and there's others like JBoss, Helidon. There's lots of different runtimes that you can choose from, and this list is constantly being updated depending on which version they are compatible with. So if you want to know, if you're already using one of these tools and you want to know if it's compatible, you can just head straight to the link where it's microprofile/compatible, and that will tell you which ones you can use. So microprofile metrics was one of these APIs that was introduced. And this was really, again, this is all about standardization. It's about providing a unified way of doing something. In this case, a unified way of exporting monitoring data, in other words, pretty much like telemetry data, to management agents and a unified Java API. So this is all about enabling that monitoring behavior in Java APIs and within Java applications. So this can be a really great way of implementing metrics if you've not already thought about it. However, many of you are probably already instrumenting something along these lines already. So this leads us on to the final one, which is traces. And this is because metrics, although they're really useful in terms of providing that behavior over time, that numerical data that we can transform and work statistically, it doesn't necessarily give us that extended context of how a particular request sort of transpires, and if something were to go wrong within it, where that error occurs and why. And this is where distributed tracing can be really helpful for this. This is where we can essentially record the path that's taken by requests as they disseminate through, as I said, this multi-service architecture that many of our applications in the cloud will be using. So what it allows us to do is provide that context and be able to map out that path so we can understand how those requests are occurring. So without tracing, it can be really challenging to precisely pinpoint the cause of performance problems in a distributed system. So it helps to improve the visibility of an application's health, and it enables debugging behavior that can be difficult to reproduce locally because of this distributed nature, and we don't necessarily have exact replicas on our local machines. Now, when it comes to tracing, there are some key concepts to understand. I'm going to be doing a tracing demo, so I'm going to whiz through these concepts. Please bear with me if you have come across these before and you're an expert. I apologize. I just want to get everyone on the same page before we deep dive into this demo. So when it comes to tracing, there, as I said, key concepts you need to understand. The first one, kind of obvious, a trace. What a trace is that represents a request and usually consists of multiple spans. So you can see in the image here, we have the orange is the trace, and you can see that we've got the individual spans that sort of make up that trace. A span is a representative of a single operation in a request. Normally it contains data, for example, like a name, time-related data, log messages, and potential metadata that gives us information about sort of what's going on within that transaction. So this is where we're starting to get into understanding a bit more about what's going on, not just watching it go from A to B. And as you can see, this diagram is kind of illustrating how a trace can begin in one microservice and then continue on through the different APIs, through the different microservices, and that's why it's useful to be able to trace it all the way through. So in this case, we're using HTTP requests between them. Now, on top of this, another key concept to bear in mind is context. So context is an immutable object that is usually contained within that span data, and what that allows us to do is basically to identify that unique request that each span is part of. So normally it's consisting of two different values within context. One is a trace identifier and one is a parent identifier. So the trace identifier is a unique identifier that's generated in the root span. So that first one on the left-hand side here, you can see we've got span ID ABC123. And essentially this is repeated so that you can understand that that same trace identifier, basically you can watch the trace all the way through by using this trace identifier, because you can understand that that span is in that trace. Then we've got the parent identifier. Now this changes because this is essentially the ID of the parent span. So where did this request come from? So that we can locate not just that that trace went wrong, but where in that trace did it go wrong, depending on the parent ID. So this can be really helpful to understand sort of and directly pinpoint where in that particular transaction things went wrong. So with these two values, essentially any operation, it's possible to determine the originating root service and to reconstruct all of the parent and ancestor services in order that led to that current operation. So this is really about, again, enabling a higher level of visibility and transparency in terms of understanding that behavior within our application. So distributed traces, metrics, and logs are the three key pillars that we're trying to achieve when it comes to our application. You're probably already implementing logs, you're most likely already implementing metrics, but the question is, are you implementing things like distributed traces in an effective manner? And the way that we can utilize all of the above is through things like OpenTelemetry. So in the past, the way in which code was instrumented, which is kind of what we're focusing on, this instrumentation, this first step, would vary, because every observability backend had its own instrumentation in libraries and agents, so you had to be able to understand each particular tool and how to utilize it. And if you changed backends, you had to change your tooling, you had to change your code, you had to change your implementation. And it was all a lot of effort and work and headache. Going back to that Sheldon meme. Not very fun. We want to be more like the aliens in Toy Story, like fun, joyful, we love the cloud. So in order to do this, basically, OpenTelemetry set out to be able to provide a standard for everyone to be able to use for this instrumentation. So it provides this sort of, again, high quality, ubiquitous, and importantly here, portable telemetry to enable that effective observability. Originally, we had sort of different standards and frameworks, like, for example, OpenTracing and OpenCensus. So OpenTracing provided a vendor-neutral API for sending telemetry data over to observability backend, but the issue with OpenTracing is that it relied on developers to implement their own libraries to actually meet this specification. We then had OpenCensus at the same time. This provided a set of language-specific libraries that developers could use to sort of instrument their code and send it to any one of their supported backends. However, the issue with this is we have two standards. That's not a standard. A standard is one standard. So it still wasn't a standard. So these kind of got combined because people realized a standard it means one thing, right? You have to have a standard when it's referring to sort of the same behavior, the same capabilities. So this is where OpenTelemetry got introduced. It's kind of a combination of OpenCensus and OpenTracing. If you are using these have now they're now out of service and out of support, so you can't go and utilize OpenCensus and OpenTracing anymore. You would have to go in and start using OpenTelemetry. So this OpenTelemetry basically offers a pluggable architecture that enables you to add technology protocols and formats easily. It's supported by loads of different open source projects and tools, and includes things like Prometheus metrics, that format, which allows you to be able to store and query metrics data, but it also allows things like integration with Jaeger and Zipkin, and the ability to have those distributed traces effectively. Now, the key part here to bear in mind is that OpenTelemetry, as amazing as it sounds, is not a full observability backend. It is there for you to use to instrument, generate, collect, and export telemetry data, but it is not there to satisfy the second and third steps that I mentioned around analyzing and visualization. It does not cover those parts, those steps, which is why we're just focusing on that first step, instrumentation. That's the part that it plays. So if you wanted to be able to visualize, analyze, etc., you'd need to be implementing it alongside things like Grafana, Kibana, etc., depending on what you want to use. But it is a fantastic way of standardizing this. So the way that it works is a bit like this. So we have sort of a variety of different sources that we're collecting data from on the left-hand side here. We're collecting those, sending them into this central OpenTelemetry collector, and then we are exporting that data to whatever we want to export it to. In this case, we've got some data storage on the right-hand side. In the diagram, I have got this acronym OTLP coming from biology. When I joined software, it was like everyone was speaking Latin, because I swear every other word was an acronym. So I try to explain acronyms, so let me know if I don't in my presentation. Just stick your hand up and I'll define it. But OTLP is short for OpenTelemetry Protocol. It's basically just the specification that describes the encoding, the transport, and the delivery mechanism of that data. So it's how we get the data inside and outside of that collector. Now, what happens within that collector is it kind of looks a bit like the following. So essentially, we have our sources here, so our receivers coming in with that data. And then in the middle here is where we've essentially got the processing going on. So this is where you might be doing things like batch, retries, you might be filtering, for example, depending on what you need to do to that data. And then we're exporting that data to whatever we need to export it to on the right-hand side. And as I said, this implements and sort of can utilize a variety of different collection and export sort of tools and technologies. So this is not an exhaustive list of what you can connect it into. There are lots more that you can utilize as well. Okay, so now that I've convinced you that OpenTelemetry is kind of cool, how do we actually make use of this? Because it's just a specification after all. So this is where we need to be considering implementations of it. And one such implementation is microprofile telemetry. This is a pretty new technology. So this has only come about in the release of microprofile 6. Essentially, it adopts OpenTelemetry. So we are utilizing that underlying technology. However, the thing to bear in mind here is the OpenTelemetry specification enables things like metrics and logs to be collected and utilized. However, microprofile telemetry, so the microprofile implementation, just focuses on tracing. Now, it's hoped that in future, we'll be able to integrate the additional capabilities of logs and metrics, but right now, it's not possible to do with microprofile telemetry. So just bear that in mind. That's why we're mostly focusing on traces for this particular sort of demo that I'm going to be doing. But essentially what it offers is it offers sort of the ability to be able to manage that telemetry data, in this case specifically traces, when you're using microprofile and Jakarta EE and sort of any Java application. There are 3 different ways that you can instrument microprofile telemetry. There's automatic, manual, and agent. I'm going to be demoing the automatic and manual. I'm not going to be demoing the agent, just in the interest of time. So with automatic, if you're already using Jakarta RESTful web services and things like microprofile REST client, you will be able to automatically enlist in distributed traces and be able to display that using microprofile tracing. Manual instrumentation, so if you have, for example, if you're utilizing CDI injection, for example, you can utilize the @inject tracer or @inject span. You can also utilize the annotation @withspan to be able to manually add in traces into your application if you so wish. So that's the manual one. And then agent is where we're using OpenTelemetry Java instrumentation to be able to gather that without any code modification. So as I said, I'm not demoing that, just the top 2 today in my demo. The way that it works is, as I said, it's kind of similar to that diagram you saw before, but in this case, I'm just showcasing it sort of how our application is working here. So in this case, we have 2 microservices running on OpenTelemetry. We've got some requests and responses going in and out. And in this case, we're just tracking the span and providing some context when it comes to the sort of communication that's going on between the microservices. We're then exporting that, because remember, this is not a full observability backend. So we're utilizing things like, in this case, we're utilizing Jaeger to be able to actually store, manage, visualize, etc., that data. So, demo time, because everyone loves a demo, and we've got about 15 minutes left. So hopefully I'm bang on time with this. So we're going to be utilizing for this demo OpenTelemetry. Anyone heard of OpenTelemetry? Nice, few hands. Yes, thank you, people. Okay, so if you've not come across OpenTelemetry, check it out. It is an open source runtime or cloud native runtime that allows you to be able to effectively make cloud native applications. These are some of the benefits that you get with it. So sort of the ability to just focus on your code, the ability to be able to make iterative changes. So if you've not come across Liberty, maybe you're familiar with alternatives like, for example, Quarkus. They have a feature called Hot Reload. We have a very similar feature called Dev Mode. So it allows you to be able to, in an agile manner, monitor changes to your code, and without having to tear down your application, basically rebuild the classes that you've changed, so you can see the changes you've made in an iterative manner without having to tear down your whole application and restart it. So really allowing that fast and iterative changes to take place. Easy to write tests, so we've got integration with a lot of different testing frameworks, including test containers, if you wanted that true to production style testing. And the nice thing with this is that it's modular. So really, you can use the features that you want, and you don't have to use anything more. So you can really make sure that your memory footprint is as small as possible, so we can be as effective in the cloud as possible. So if you are interested, then we've got an article. My head's covering half of it, but you'll see afterwards. It is basically about like the reasons why you might want to try OpenTelemetry, or just head to openliberty.io, and we've got a load of different documentation on there. Or alternatively, follow us on social media. I run them. I'll say hi, and love the fact that you're following. So with this, we're going to be diving into the demo. It's roughly based on this open source GitHub repo that we have. At the moment, the demo I'm going to show is based on our guides. So on the OpenTelemetry website, we're quite proud of the guides that we have. It's a way in which that you can have a go with the technologies that we implement without having to sort of set up a whole new demo application. We are developing a guide currently that uses microprofile telemetry, and we just about managed to get it in draft mode ready so I can demo it. Hooray! But what it does mean is that unfortunately you guys can't access it just yet. It will be ready in sort of production in a couple of weeks. So at the moment, this is sort of the best way if you want to go away afterwards and have a go yourself. This is the best way to do it, using this repo to have a go yourself. But the GitHub's there. It's all open source. Check it out if you want to. So with that, I'm going to stop that, and hopefully, damn it, it did log me out. I had it all set up and ready, and unfortunately, it doesn't like me. Right, can you see that? Stay? Are you alive? Okay, maybe. Yeah, okay. So we'll give this a go. So what we have here is, I'm going to go to the next diagram. Here we go. This is, so as you can see, this is just like the diagram I showed in the slides. Essentially, in this demo application, it's fairly simplistic, because the idea is not to bombard you with the complexity of a full production enterprise system. It is just to teach you a technology. So we've tried to keep it simplistic so that you can just focus on learning the technology instead of having to learn the application. So in this case, we have 2 microservices, inventory and system. The system microservice every 15 seconds is scraping system data. And then the inventory microservice is essentially finding out that data from the system microservice and storing a list of it. We can access that list through a REST endpoint to be able to understand the latest data and how many systems we have in our sort of application. In this case, we're just doing one inventory microservice, and we're just deploying one system microservice. We're going to be setting up OpenTelemetry using microprofile telemetry in this demo so that we can understand how the spans are occurring and sort of trace through our requests through our system. So with this, let's just check that this is still up and running. Yep, perfect. So I've actually started both the inventory and the system microservice using dev mode. That was the mode I talked about just now. So what that means is I don't have to go away and keep redeploying my application. It's just going to be listening out for changes and updating that application as I make those changes, which is hopefully going to make this a lot quicker to go through. This first page here, so all of our guides look very similar to this. They're all the same format. So if you want to have a go with any of the others, you'll be familiar with it. We have the instructions on the left-hand side, a terminal roughly based on like Thea on the right-hand side, an IDE, and then a terminal at the bottom. Most of our guides run using the same application, that's system and inventory, so you should be able to follow along if you want to have a go at any of the other guides. So in this case, this first page, I've already cloned the repo. Again, this is all open source, so you can go and have a look if you want to when this guide is published. But in this case, as I mentioned, I'm relying on Jaeger for my backend system. So I've got Jaeger up and running using sort of just these basic scripts and sort of using Docker, and you can look at Jaeger documentation if you want to find out more about that, but it's not what we're focusing on today. So essentially, I'm just going to skip this because this next part is looking at the finish directory. So if I open up my directory structure, make this a bit bigger so you can see, in every guide that we produce, we have a finish and a start directory. The finish directory is what you should get to at the end of all the instructions. So if you want to cheat and just go straight to the finish directory, you are more than welcome to. Or if you want to check what it's supposed to be before you start, that's a good way of doing it. Or if you come into errors or bugs that you might have introduced, you can always compare it to that finish directory as you're going through the instructions. But we're going to be starting from the start directory because that is where we start to be able to follow the instructions to reach the state of the finish directory. So that's why I'm just going to skip this in the interest of time. This is just showing you what it will be like at the very end of the instructions. And then the next step is just building the application. In the interest of time, I went ahead and did that for us. So as I said, we're using, in this case, Maven. You can use Gradle with OpenTelemetry. You can even use Ant if you really want to. But we're just using Maven just for demo purposes. It's not a preference. It's just a standardized way of us keeping all the guides the same. So in this case, we're using Maven and we're running it in dev mode, so we are listening out for those changes. I've already started the inventory system, the inventory and the system microservices. We know they're up and running when we see this message saying Liberty is running in dev mode, so we know it's ready to go. So now, if I've already got, that's the system, and as you can see, same message for the inventory microservice here. So now if I go to a new terminal and enter these curl commands, perfect, it's still up and running. What you should see is that our system microservice is there ready to use, and perfect, so is our inventory microservice. So we know that we can carry on to the next step. Okay, so now that we're at a stage where we can actually focus on microprofile telemetry, what is the first step? Well, the first step we need to do is to be able to enable it as a feature within our server.xml. So we have to do that for both the inventory and the system microservice, so you'll see me repeating some steps throughout these instructions. So we've created these very handy little buttons that do it for me, which is quite handy. If you want to go through the directory structure and find it yourself, that's totally fine as well. We provide where it is to be able to find it manually if you want to do that. But I'm just going to do the button in the interest of time. So in this case, you can see my server.xml. Now, in this case, we do provide for all of the changes you need to make to a file, we provide this copy button at the bottom right-hand side of the sort of code. So you can just copy that, select everything and paste. Please remember to save because this doesn't auto-save. Or you can just compare them and look at what's different and implement that yourself if that's what you'd rather. So in this case, what we're adding here is this feature for microprofile telemetry. That's the main addition we're adding here. We've already got some other microprofile and Jakarta features in here. So things like CDI, JSONB, using RESTful, for example. But the main thing we're adding and we're focusing on today is telemetry. So we're going to have to, so we've done that for the server. Now we'll do it for the inventory microservice. Again, it's pretty similar. As you can see, we're missing microprofile telemetry here. So we're just going to paste that in. We've also got the addition of microprofile config in this particular microservice. So now that we've done that, the next thing we need to do is create a config properties file. Kind of weirdly, microprofile telemetry is automatically off. So you then have to enable it using microprofile config. So to do that, we're going to use this touch command. For all of our commands, we have either an execute or a copy button. So if you want to do the manual copy, paste, enter, you can do that, or you can just hit execute and it will do it for you, which can save some time. So in this case, we're just going to open up this new microprofile config properties file. And what we're adding in here is these 2 lines of code. So it's fairly small. What we're adding here is essentially the OTel service. So that top line I have there. This is essentially just setting the system service name And then that SDK disabled property setting to false enables us to have that tracing. So you do definitely need that line in if you're going to enable microprofile tracing. So we're going to need to do the same thing for the inventory microservice. Again, it looks identical because we're having to do this for 2 different microservices. So just going to copy and paste that in. But in this case, instead of system, we've named it inventory, obviously. Okay, so now that we've got that all set up, so we've enabled it in our server.xml, and we've got the microprofile config to actually enable tracing instead of it being off. Now what we can do is see what kind of traces we get. So the first thing I'm going to do is use this curl command to be able to actually run the system and inventory services. So if I click this, that will run it essentially for me. And then what we can do is, perfect, that's run. We can visit the Jaeger service, and that will start to show us some of these traces in more of a visual format. So for example, if we go to inventory and I do find traces, perfect. So you can see I've got 2 inventory traces and 1 system trace here. I can even click on that and get some additional information. So for example, I can see this was a GET request, and I can start to see, yeah, I've got a status code of 200. I can even start to click on this and get some more detailed sort of breakdown of that particular span itself. So let's have a look. Yep. So we've matched what it should show here. And verified that we have 2 spans from inventory and 1 span from system. And as I said, you can view the details by clicking into them itself. So that was essentially using the automated. Now we're going to take a look at enabling it manually, which was that second way of implementing microprofile telemetry. So in this case, what we're going to be using is, so firstly, we're going to enable OpenTelemetry APIs to trace all of our REST endpoints by default in the previous section. Now we're going to be using the @with_span annotation to enable particular methods to show in our tracer by using this tracer object. So the first thing I need to do is I've got to add some more to my pom.xml. So again, I'm just going to open that up and copy and paste this in. Essentially what I'm adding here is 2 dependencies. So paste that in, remember to save. What I'm adding in is, quickly find it, here we go. So the OpenTelemetry dependency and the OpenTelemetry instrumentation dependency. So you will need these 2 dependencies to be able to do this, so make sure you have both. And now I'm going to, again, just replace some of the server.xml. So in this case, this is the inventory service. And what I'm doing here is enabling it I'm basically exposing it as a third-party API in OpenTelemetry. Now, to add visibility of OpenTelemetry APIs to the application, we do need this third party to the types of API packages that this class loader supports. Instead of explicitly listing out the API packages that include third party, we can just set plus third party value to the API type visibility. And what that allows us to do is basically add third party to the default list of API package types that are supported. So it's kind of a shortcut way of doing that. So you can see it added here in these 2 lines with a comment. So hopefully that's clear. So what we're going to do now is enabling tracing in Jakarta CDI beans. So as I said, this is using that @with_span annotation. So if we head over to this class inventory manager, and in here we're going to replace with the code provided. I haven't saved. It doesn't like it when I don't save. Inventory manager, copy, paste, save. Okay, so with this, let's just check. Aha! I'd pasted in there. Sorry. There we go. Okay, so with this, we have this @with_span annotation that I was talking about. And what we've also added is this @span annotation, which allows us to be able to essentially customize the host parameter, customize value to indicate that it's part of that trace. So in this case, I'm just going to prove that this is live by adding in JCon, because we're at JCon. So now what I can do is a new curl command to be able to, again, run the system and the inventory microservice. And now what we should be able to see when I go back into Jaeger is that this is specifically started with that @with_span annotation. So if I go back to Jaeger, back to the home page and refresh, and now if I find traces, perfect. So you can see this was started a few seconds ago. If I go further into that, take a look at Inventory Manager, take a look at the tags, and, am I on the right one? Let's have a look. Where's it gone? Should be in tags, so maybe I've not set it up correctly. Let's just check I've saved. And do this curl command again. Sorry about this. Alright, if I go back, refresh, and then find, cool. Okay, I don't know why it's not showing up, but what it should show, as you can see in this diagram, that's because I've not done the second curl command. There we go. You can tell it's live. Sorry about that. So I need to do the second one, which is what actually generates the @span attribute. That's what I was missing before. So now if I refresh on my Jaeger, and again, search for my new span and trace, there we go. Perfect. Now when I go into it, what you can see, there we go, is that host name JCon. So you can see that I've actually created this using that annotation manually rather than just relying on the automatic implementation. Okay, there's more to this guide that you can check out later. In the interest of time, we don't have time to, but you can, for example, create a custom tracer object as well. So with that, I'm just going to wrap up because I know I'm kind of over time. I apologize. So hopefully what I've shown is that we are entering a world of increasing complexity, and that effective observability is crucial for us to be able to understand and enable our applications to be effective in the cloud. But you're not alone. There are loads of different open source technologies you can use, including microprofile telemetry. As I said, if you fancy some more homework, you want to research this a bit more, check out the following resources. I will be uploading my slides online as well if you don't want to take a picture. Just some useful, helpful links. And when the guide is up, I'll be sharing that on my social media, so check that out as well. As I said, we got loads of other guides that you can check out if you're interested in any of the other microprofile specifications, for example, or anything else in observability. You can try those out either locally or in our cloud-hosted environment. So all you need for this is a browser. So if you've got like a restricted machine, this can be super helpful in terms of trying out the technology without having to download anything locally. So that's what I was using for the demo today. As I said before, connect with us if you want to find out more or know when that guide's going live. I help run them, so I'll say hi. And with that, thank you very much for sticking with me. Appreciate it.